Lesson 1.6, Multiplying and Dividing Real Numbers. To go over the rules for multiplying and dividing by real numbers, positive and positive equals positive, positive and negative equals a negative, and a negative and a negative equals a positive. This is true for any decimals, fractions, integers when multiplying or dividing. Today I want to mostly stress the importance of dealing with exponents because exponents are repeated multiplication and there are some different types of negative bases when dealing with exponents. But first, just a quick review. An exponent is an example here. You see 2 to the 4th power. 2 is the base and 4 is the exponent. And the number 2 is the number that is being repeatedly multiplied by itself. And the exponent 4 shows you how many times you will multiply the base times itself. So for this example, you can see that there's a correct and an incorrect way to do this. So I like to show the incorrect way because it is a common mistake. So the correct way to evaluate 2 to the 4th power is 2 times 2 times 2 times 2. The incorrect way, and often commonly used mistake, is 2 times 4. That is not correct for evaluating exponents. What I want to focus mostly on is what to do when there are exponents and negatives involved. There are 2 different scenarios you will encounter. You will encounter some examples with parentheses around the base, and there will be some examples where there are no parentheses or without parentheses around the base. So let's first look at the types when they're with parentheses. So for this first example, negative 3 to the 4th power, this is how you would expand or evaluate this example. Negative 3 times negative 3 times negative 3 times negative 3. If you evaluate this, negative times negative is a positive. So negative 3 times negative 3 is a positive 9. And then bring down the other 2 that we haven't used yet. 9 times negative 3 is negative 27. And then negative 27 times negative 3 is a positive 81. For this second example, same idea, but this time there are 5 of them. So negative 3 times negative 3 times negative 3 times negative 3 times negative 3. So the first 4, we're going to get the same result that we just got over here, and then we're going to multiply that 81 times a negative 3, and you'll get negative 243. If you notice, the example on the left is a positive and the example on the right is a negative. And that's because here on this example on the left, there is an even number of negative numbers, which means all of the negatives will cancel out and make it a positive. In the example on the right, we have an odd number of negatives, which means we will always have that one extra negative left over that will make our answer negative. That is always true for an even and odd exponent as long as there are parentheses around the base. So just to recap, this is with parentheses. When there is an even exponent, our answer will be positive, and when there is an odd exponent, our answer will be negative. Now, if you are evaluating this on a calculator, you must make sure you enter parentheses around the base number. So in that first example, you have to make sure that you put parentheses just around the negative 3, not around the exponent 4. So if you know how to use exponents on the calculator, usually you use that caret button. So you would have to type the buttons in this order rather than putting parentheses at the beginning and the end. It has to go just around the negative 3. Okay, so just a couple examples here. You can kind of work through these to see if you think they would be positive or negative, just to get a little practice. This one would be positive because of the even exponent. Negative, 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 positive. This one would be positive because if you notice I snuck in here, there's a positive base. There is no negative, so there is no way this one would be negative. Okay, so let's compare now with and without parentheses. This is where it gets a little tricky. So this one, just like the ones we just did, would look like this when we expand it. -2 times -2 times -2 times -2. And if you evaluate that, you end up getting a positive 16. For the example on the left, on the right, without parentheses, this looks a little bit different. So we actually are not calling this base -2. The base is 2. We're raising 2 to the 4th power, and then you're making your product negative. So it kind of looks more like this. If you follow the order of operations, it's almost like, or you could look at it like this, -1. Kind of sneak in a hidden -1 there. But basically, you're evaluating 2 to the 4th power first, which is 16. And then you're multiplying it by -1, which becomes -16. This is true for regardless of what the exponent is. In this case, without parentheses, your answer will always be negative. So exponents without parentheses are always negative, and again, that's because you follow the order of operations. You do the exponent first, and then multiply your answer times -1. So let's take a look at some more examples. You can think through these and see if you think they will be positive or negative, and see how you do. This one will be negative because there are no parentheses, even though the power is even. There is no parentheses, so it is negative. This one will be positive, negative, negative, also negative, positive, positive, negative, negative, and negative. Okay, so where this really comes into play is when you're evaluating expressions. If you have to replace a variable with a number, if that number is a negative number, you must put parentheses around it. There is not necessarily going to be parentheses in the expression. You have to put them in yourself. So let me show you an example of what I mean. So in this expression, first thing I need to do is replace my x with a -1. But x has an exponent. If it doesn't have an exponent, this doesn't necessarily affect the problem. But since there's an exponent here of 4, it's really important that I put parentheses around my -1. And I'll show you what happens if you didn't. So this is the correct way in the middle, and then I'm going to show you the incorrect way and how it could change the problem on the right. Okay, so this over here is the wrong way, and I just want to show you why it's important that you do this the right way. So if we evaluate this, -1 to the 4th power is +1. 3 plus 1 is 4. 4 to the 2nd power is 16. And 7 minus 16 is -9. If you do this incorrectly and you do not put parentheses around the -1, what happens is you actually get a -1 when you do -1 to the 4th power. If you do it on your calculator and you don't use parentheses, you'll get a -1. And then you can see how instead of being 3 plus 1 is 4, like we got over here on the left, you actually get 2, because it's 3 plus a negative 1. Then you get 7 minus 4, which is 3, and that's a completely different answer. Okay, so you have to be very, very, very careful that when you are plugging in a number into an expression, you're putting parentheses around it. So right here is where the key is. Make sure you're putting parentheses around there. Again, this is really only imperative if there's a power exponent of 4. If there is no exponent, you can get away with not using parentheses. But with exponents, you have to put parentheses around the base, especially if it's negative. So you want to be very, very, very careful to distinguish between the two with parentheses and without parentheses, because as you can see, it is possible that you might get the wrong answer. Okay, here are just a couple other examples. If you want to just give them a try for yourself, I will write in the correct answers, but if you wanted to try them for yourself, you can pause the video. So this first one, you should get a negative 4 if you evaluate that one. And the second one, you should get 1,022.